Hello and welcome to Lemap TV or the Problem Solvers channel. Today we're going to be dealing with differentiation as promised in the last video which we treated in previous lessons. And so we're going to be dealing with tough differentiation problems, part 1. Under differentiation, tough differentiation problems which you may find difficult or which you may find in several problems you may solve on differentiation. And so we're going to be dealing with the part 1 today. We will solve a few questions, and then in the next part, in the next video, in my next video, I'm going to deal with the second part, the second type of problem, the tough ones that we actually find in differentiation. And so I'll bring up this one, and I begin by saying, supposing we have a question like this: y is equal to sine of the cos of the tan of x, sine of the cos of the tan of x. This is the function of a function question. You have y is equal to sine of cos of tan x, and remember in differentiation we have the function of a function, the chain rule as a part of the law given. And so it says here now that y is equal to sine of cos of tan x, and so the best way to solve it is to represent the values, as in give substitutes the tan and the cos and the sine with some values. So we begin by saying let tan x be equal to u. Let tan x be equal to u. So we're going to find du dx. So du dx of tan x is actually sec square x. That's if you're giving your trig functions from your list of trigonometric functions. When u is equal to tan x, the u dx is sec square x. That is the inverse of the cos. The inverse of the cos x is the sec x. So the square of the inverse of cos is the sec square x we have here. And so we now have to represent the next one. We say what we now have is y is equal to sine of bracket of cos u, because we represented u with tan x. And so what we now have is y is equal to the sine of cos u. So we'll now say the next thing. Let w be equal to cos. Say w. Let w be equal to cos u. And now doing that, you find the value, that is the differential coefficient of w with respect to u. And we'll say dw du is going to be equal to minus sine u. Minus sine u. This is the way it is. U and then w together in a differential form will give us minus sine u. And then we have the third part. When u is represented with tan x and then w is represented with cos u, and so we have here y will automatically be sine of w. And so how do you do it? We find the differential coefficient of y with respect to w, and so the y dw is equal to cos w. So we have finished the first half of this question, and so we are going to move to the second part where the function formula works. And so we say dy dx, which we actually want to find, because the question was if y is equal to sine of the cos of tan x, find the y dx. So we do not know the y dx, but now we are getting close to it. And so how do you find the y dx? The y dx is actually a multiplication of all the answers we've gotten. So the y dx is dy dw times dw du times du dx. That will give us the y dx. And so when we multiply them, it gives us the yw is cos w. So cos w times minus sine u multiplied by, what do we have? Sec square x. Sec square x will give us minus, cos w sine, we put them in brackets because they have all different values, and then the third one is sec square x. Now we still have some of them in w and u. We need to convert them completely to x values, and so we do it this way. So having this answer, we'll rub off this area so we can find the remaining part. So we move like this, and then we say minus cos W, okay, multiplied by sine U, then multiplied by sec square x gives us the y dx. But remember that W is actually cos U. So we say minus cos of cos U, then multiply by sine of U again, then multiply by sec square x will give us dy dx. Also remember that we still have U values everywhere. We have U values here and here. And so what we'll do is to bring out the U values, convert them back to the x value. And remember that what do we represent U with? U is tan x. And so we say minus cos of tan x multiplied by the sine of tan x, then multiplied by sec square x is equal to dy dx. The space is actually not enough, so we're going to roll up this side as well up to this area. And so our final answer, the question remains that y is equal to sine of cos of tan x. And so we move this way and say the y dx is actually, okay, minus cos, you open another bracket, cos again of tan x. As you can see, it's going to multiply it again by sine of tan x, and then finally multiplied by sec square x. Now, like I said, y is equal to sine of cos of tan x. Therefore, the y dx will give us minus cos of tan x multiplied by sine of tan x and then multiplied by sec square x. Now, there's no other way to join these things together except to separate them in this method and then release your answer like this. So we have several other complicated means of complicated questions, and so in my next video I'm going to release those questions and explain as many other formulas and methods you can use in order to deal with this kind of complicated problems. So in my next video we'll be dealing with tough differential problems part 2. Subscribe to this channel in order to get and watch the beautiful and awesome and amazing videos I will release in the next videos. Till we meet again, stay safe, stay home, stay calm, and subscribe. Watch my videos. You won't regret it. Goodbye.